Intel and Microsoft have actually been collaborating for 20 years. We want to make sure that the software is really taking advantage of the hardware innovation that Intel provides. Intel was designing its Nehalem microarchitecture at the same time we were starting the development of Windows 7.
That gave a pretty good opportunity for the Intel engineering and the Microsoft teams to go in and look at specific areas where we can deliver features that improved upon the energy efficiency, responsiveness, and performance.
Intel actually introduced this technology, hyperthreading or symmetric multithreading, back in the Windows XP timeframe with the Pentium 4, and brought it back with the Core i7, the Nehalem microarchitecture, with some improvements. The Windows XP scheduler had some logic in it to try to keep the threads on different physical CPUs. We've gone further in Windows 7 with the scheduler having some modifications that are actually even more intelligent about placement of threads on hyperthreaded systems. Intel introduced 6 new instructions in their upcoming Westmere microarchitecture that Windows 7 will take advantage to speed up AES encryption and decryption to minimize the impact when you're reading to and from a disk.
There was a pretty concerted effort between Intel and Microsoft looking at Intel platforms running Windows 7 to make sure that you minimize the resume time, the shutdown time, the boot time, and the startup time as much as possible.
One of the ways that we improved the boot time was to actually parallelize large parts of it. We'd parallelize some in previous releases, but we went even further in this release. To get the performance for the parallelized paths, you actually need multiple cores. Intel introduced some new power management knobs in the Penryn and the Nehalem microarchitectures, and as we were developing Windows 7, we looked closely at how we could take advantage of these knobs. One of the knobs, for example, is speed step technology, which allows the operating system to ratchet up and down the performance of the CPUs at the appropriate times so that the workload can execute as efficiently as possible. Another enhancement that they made was deep power down in the Penryn architecture, and then they improved it in the Nehalem architecture. And what that state does is allow the processor to go into very deep sleep, but only if it's idle. We looked at ways we could minimize to enable the processors to get into deep sleeps and stay there. We've added APIs and modified the operating system to try to get idle and stay idle. We've got something called tick skipping, where we don't actually wake up an idle CPU to deliver a timer tick into it. For example, to update the time of day. We've got something called timer coalescing, so that drivers and applications that have timers that have the same period of timer tick, but they were offset with each other by a slight amount, and align those two periods exactly on top of each other and service both of them with just one tick, and end up waking up the CPU once and not multiple times. If you're not actually consuming power on the CPUs, that can enable the battery to last longer, for example, because you're not drawing energy from it.
This allows PC OEM vendors to build more energy efficient platforms using Windows 7 on the Penryn and the Nehalem microarchitecture based processors.
Key part of managing power is not just at the machine level, but across an enterprise. And there's features in Intel's latest processors with vPro technology that allow it to report what power state the system is in. So the software like System Center, Configuration Manager, can actually query the systems for their power states and then take action based on what they're doing. Enterprise Administrator can take advantage of processors with vPro technology to power on and power off those machines remotely, to manage power efficiency and power usage across their whole enterprise.
One of the key scenarios that Microsoft and Intel have focused on is to allow IT to go ahead and very easily upgrade their entire installation of PCs to Windows 7.
Intel vPro technology introduces features that make it much more efficient to roll out an operating system to an enterprise. When you roll out an operating system, you really want to do it when people aren't at their machines. So you typically want to do that at night when the systems are off. You need a capability to wake up those systems, and vPro has a remote capability that will power on those systems. The previous implementations had a limitation where the wake on LAN packet would not be routed outside of a subnet, so that doesn't scale to most enterprise network configurations. With vPro, you can actually send TCP/IP packets that get routed to the target system and wake up the machine. So with the System Center Configuration Manager, it will allow an administrator to schedule an operating system deployment at an off-peak hour. And once the installation is complete, you can power off the machine remotely. So an end user comes in the morning, powers on their machine, and it's been magically upgraded to Windows 7. The combination of System Center and vPro allow an administrator to securely manage out-of-band Intel vPro systems.
It is very important that these capabilities are as secure on a wireless network as they are on a wired network.
And with vPro technology, Intel has made it possible to have vPro authenticate itself to secure wired networks or wireless networks. And System Center Configuration Manager for a long time has had the ability to go and harvest audit logs from the operating system. vPro has its own secure audit log and will record remote vPro management and other change events that occur on that system. System Center is able to go and query vPro for that audit log and then integrate that information. An administrator with vPro systems actually has a more complete view of what's gone on those various systems.
Intel and Microsoft have a very long history of jointly innovating.
So I think in the coming years you're going to continue to see this tradition go forward, where Intel is innovating at the hardware level, we're innovating at the operating system level, making sure that the software and hardware both meet and deliver enhancements for customers running consumer and enterprise workloads.